This part continues the evolutionary journey of invertebrate kingdom, from where we left off moving beyond flatworms into more advanced invertebrate groups. The focus here is on how each phylum adds a new upgrade. If you track those upgrades carefully, classification becomes almost automatic.
The first major upgrade after flatworms is the appearance of a body cavity, though not a true one yet. Achelminthes or nematodes are pseudocoelomates. They are organ system level, bilaterally symmetrical and triploblastic. One key structural feature is the complete alimentary canal food enters and exits through separate openings. Excretion happens through a tube system with a defined excretory pore. Here's a trap you need to be careful about. These are the only pseudocoelomates in your syllabus. That line is directly tested. Also, females are often longer than males. Another subtle but common question point. The next upgrade is the appearance of a true coelom and segmentation. Annelids introduce metamerism. The body is divided into repeated segments. They also show the first closed circulatory system. Their nervous system has paired ganglia connected by a double ventral nerve cord. Locomotion is achieved using circular and longitudinal muscles, and in aquatic forms like nereis, parapodia help movement. Reproduction varies. Some are dioecious, some monoecious. If you see segmentation plus closed circulation, you should immediately think annelids. Arthropods take complexity to another level. They have a chitinous exoskeleton, which acts like armor. Their body is divided into head, thorax, and abdomen. Movement is through jointed appendages. Sensory systems become highly developed: antennae, compound eyes, and statocysts. Excretion is done through Malpighian tubules. Respiration varies: gills, book lungs, or tracheal systems, depending on the organism. This phylum is all about mobility, protection, and sensory advancement. Now we will see arthropods to real-world relevance. Some are economically useful, like apis, honeybee, bombyx, silkworm, and lacifer, lac insect. Some act as disease vectors: Anopheles, Culex, and Aedes mosquitoes. Some are pests, like locusts. And one special case stands out: Limulus, the king crab. Here's something important. Limulus is considered a living fossil. That's a direct exam favorite. Molluscs introduce a very different body design. They have a soft body with a calcareous shell. The body is divided into head, muscular foot, and visceral hump. The mantle forms a cavity that houses gills. A unique structure here is the radula, a rasping organ used for feeding. Here's a trap you need to be aware of. Even though they have shells, mollusks are not segmented like arthropods. That confusion shows up often in questions. Examples help anchor the phylum: Phyla, apple snail; Pinctada, pearl oyster; Sepia, cuttlefish; Loligo, squid; and octopus are all mollusks. Most are dioecious, oviparous, and show indirect development. If you see diversity in body forms but a common soft body plan, you're likely dealing with Mollusca. Echinoderms introduce one of the most unusual patterns. Adults show radial symmetry, but larvae are bilaterally symmetrical. That shift is extremely important. They also have a water vascular system, which helps in locomotion, feeding, respiration, and transport. Another key point: there is no excretory system. Examples include starfish, sea urchins, sea lilies, and brittle stars. Here's a trap. Never mix adult symmetry with larval symmetry. That confusion is very common. Hemichordates sit in an interesting position. They were earlier grouped under chordates but are now classified separately. Their body is divided into proboscis, collar, and trunk. They have gill slits and an open circulatory system. Respiration occurs through gills and excretion through the proboscis gland. The key clarification is this: their stomochord is not a true notochord. That is why they are not chordates.
We will now look at some major differences between chordates and non-chordates. Chordates have a notochord, a dorsal hollow nerve cord, pharyngeal gill slits, a ventral heart, and a post-anal tail. Non-chordates lack these features. A quick memory line helps here. Chordates, DHS, dorsal, hollow, single nerve cord. Non-chordates, VSD, ventral, solid, double. If you lock this distinction, many classification questions become direct.
Chordates are defined by 4 core features: presence of a notochord, a dorsal hollow nerve cord, paired pharyngeal gill slits, a post-anal tail. They are bilaterally symmetrical, triploblastic, coelomate, and have an organ system level organization. This is the structural blueprint of all chordates. Protochordates show early chordate features. In Urochordata, the notochord is present only in the larval stage. In Cephalochordata, the notochord runs from head to tail and persists throughout life. Both groups are exclusively marine. This difference in notochord persistence is a classic comparison question. Vertebrates represent the final upgrade. The embryonic notochord is replaced by a vertebral column. They have a ventral muscular heart, well-developed kidneys, and paired appendages. Here's the key statement you should never forget. All vertebrates are chordates, but all chordates are not vertebrates.
The final system map brings everything together as one evolutionary ladder, from
Achelminthes
to Annelida, then to Arthropoda and Mollusca, then to Echinodermata and Hemichordata, and finally to Chordata. Each step adds a structural upgrade: body cavity, segmentation, exoskeleton, specialized systems, and finally the notochord. If you can visualize this ladder as a progression of features rather than a list of phyla, the entire animal kingdom becomes a story instead of a syllabus.